Hello. Yeah. Good morning. So I am Shivji, and I have my colleague and friend Sachidanand with me. Together, we will be going through a journey when we had to re-architect our apps. Our SLAs were around 3 hours. So a batch system was there. It used to work. Now we had an SLA of 10 odd minutes. And we said, you know what? Let's make it more near real time. I'll explain that and qualify that more as we go through. But this is a story around our operations inspired by a true incident in production that we had, and where we spent, let's say, a couple of nights figuring things out and fixing the cluster. I'll tell you the whole story, and in between, what we are trying to do is staying true to the theme. When you make a system which is running in a proper batch to a very, very small batch or near real time, then what are the kind of issues that you can get into? And how do you take a step at fixing some of those? Very quickly off the block, the opinions here of yours are my own, and I don't represent my employer. I am a staff engineer at Nutanix, work in the data platform group, a regular software engineer. I've been doing a lot of meetups these days. I've been speaking at a lot of conferences. Pretty excited about distributed databases and streaming, in particular, open source databases, streaming and stuff, and communities around those. MySQL, Postgres, Apache Pulsar, Nats, Druid, and ClickHouse are some of those things where I have worked on internals. I have also contributed to a few of them. And Sachidanand, do you want to quickly introduce yourself?
Yeah. Hi everyone, I am Sachidanand. Currently, I am working in the cloud data platform team at Nutanix. Day in, day out, I work on distributed OLAP databases like Druid, ClickHouse. I also love open source. Today, we will be talking about one of such events from our experience.
Okay, so let's get started then. I'll first present a little bit of background, which involves our application, what it does, and what is that change that we made in our architecture, and the problem statement, which will take us to the heart of the talk, saying, you know what, this is what we changed, and then we can go through a few issues that we encountered and how we fixed them. Like I said, the one thing I used to do earlier, I used to talk a lot of facts, theory of distributed systems in my previous talks. Today, I am doing an operations talk. So I think these are not exhaustive. I really, really want to keep it engaging, right? So at times I'll stop, and I would really love you if for bringing up ideas saying, you know what, we could do something like this, we could do something like that. So let's keep it engaging. I don't mind if I have to skip the last few slides. I don't mind. I would rather keep it engaging, right? So I don't want to take too many questions in between because it may disturb the flow. But if you feel like you have an idea that you want to share when I ask for ideas at some point, or if you feel like at some slide you are stuck, you can't move ahead through the story, just put your hand up and we'll take that question and move along. Towards the end, we will try to have more questions. So on the application context, so we basically have a dashboard in Nutanix where there are a few graphs and there are filters. So people can choose the filters, and on the graph, it will fire analytics queries, bring the data and show the graph, right? And this query will directly go to a running instance of our analytics database, which is Druid here, and get the data from those queries. The requirements, operations obviously has to be easy. So Druid in this case has to be multi-tenant. A lot of customers, everyone's data and queries are being served from the same cluster. But you also need to have fine-grained isolation. Some customers are huge. They have a lot of data. Some customers are small, and there are a lot of small customers also. There are a few big customers as well, right? And isolations for all of them, at least to support phased rollout when we do re-architecture like that, or a database upgrade, an application upgrade or something. We should be deploying in a phased manner. The last talk was a lot about workflow. So I will not go into temporals. We will be presenting a talk on the temporal meetup that Platformetry Group will be organizing shortly. So we'll take temporal story there. The other parts of the stack you can see here. I will actually talk more about Druid today than the others. But in the stack, the other things you can see is we use S3. That's the backbone of our data for this app. And our workers in this workflow are mostly written in Java, backed by Postgres as their data store. A little bit about the use case, right? So Nutanix is this company which makes data centers for its enterprise customers, right? You see a pic at the back about a data center, right? You see a few wires and stuff, right? So what we are trying to do in this use case is you have a lot of VMs that you make. In AWS case, if you have used AWS, you have many EC2 instances. And between these EC2 instances, there is data flowing through those, right? The network. So between VMs, there is data flowing. Between IPs, there is data flowing. And we are saying we are going to track those network packets. And on the dashboard, our customers can see for their infrastructure where their data is flowing, which two VMs are connected, all kind of visualizations there in their infrastructure, right? So we had some sort of thing there already. We had an S3 bucket where this data was enriched in some way and put it on S3. And this is where our architecture starts, where we would take all that data from S3 and ingest into Druid. And Druid would then serve our analytics dashboards and ML engines. So this is our old architecture, right? And we will talk about, we went to new architecture and what are the kind of issues we faced and fixed. So the old architecture basically said that I told you the enriched data will be there on S3. Now, every 3 hours, there will be a cron that will run. It will nudge the ingestion pipeline. Ingestion pipeline is backed by temporal. The ingestion pipeline will make sure that data from S3 is being ingested into Druid. And then Druid will do its offline stuff and all to make queries efficient. Then these queries will power our analytics dashboards and our ML engines, right? So this is clearly a batch system with 3 hours, in one ingestion after 3 hours, and then another ingestion after 3 more hours. We change this system to say, you know what, we will make this cron's duration configurable. We'll start with 5 minutes, right? So we still run at around 3 to 5 minutes. So every 5 minutes, you will take the batch of data that you had accumulated for that customer, whatever network packets are flowing, and you will ingest it into Druid via the pipeline that we talked about, right? So every 5 minutes now, the cron will nudge the ingestion pipeline backed by temporal to ingest into Druid. Temporal, like we saw in the last talk, is a state machine for us. And if there is something that happens on the Druid, like you'll see in the talk today, if ingestion is under stress, that back pressure will be observed by our temporal stack. So this is probably easier to guess, right? If you had 3 hours of data accumulated, and then you ingest those data, one day, let's say, as an example, to simplify it, one batch of 3 hours of all the IP flow logs for one customer, you have a few huge files, right? Now we said 3 to 5 minutes, right? For every customer, there will be a bunch of small files, right? Anyone very quick guess on what could go wrong here? We will start with seeing some of those. Yeah. Yes. What's the problem with that? That I saw it here. But what is the problem? Now, if I try to put perfect, perfect. Yes, got it. And the same on query side, right? When you are trying to query too many files. Any other guesses? Let's keep it engaging, guys. There's no wrong answer. It's only wrong questions maybe, but no wrong answers. Yeah. Sorry. Right. Correct. Mm-hmm. Right. Good. But analytics use cases, you don't update old data as much, right? But yeah, quite good points. And right. And yes, correct. Any ideas how to get around these issues? Like what are some things that you would do to get around these issues? Simple ones. It's like very simple, intuitive ones that I will cover. But I wanted to make sure that I throw some ideas on a slide, but I want to get it out of you first. Yeah, I don't have a lot of time. Avinash will run behind me. So please, quickly. What ideas? Like if there is so much more files to process, what do you need in your architecture now or in infrastructure now? Perfect. I got one. I have 3, 4 simple ones. Combine files. That's compaction. Yes. Next. Mhm. Sure. Yet simpler ones. If I have to process like 5 files and if I have to process 500 files, what about the infrastructure? Yeah. Yes. Okay. Others? Sorry. Yeah, please. Perfect. That is also listed there. Yes. Bigger machines, bigger databases. Come on, like, right? VM. But yeah. Sorry. IO. Others? Right. Resources, basically scale up or scale out, right? So pretty much what we are trying to do here, right? So there is no big revolutionary idea here. It's very simple bunch of things that we will take you through and we will show you what we did. So the kind of things we'll cover is scale up, scale out, like you said, isolate tasks. So if you have a process, a big bunch of file to process, it will process. If it has 2 files to compact, it will sort of go through that, compact it, right? If it has 100 files to compact, right? Better to isolate, saying you only compact, you only query, right? Scale out, right? And maybe isolate tiers and restrict errors only to those tiers in that way, right? So the other parts of the system will still keep working. Parallelize, somebody suggested. Somebody has to sit and assign tasks to all the other people when you parallelize, right? Those algorithms have to be very performant now. Think of a load balancer trying to assign it, right? It has to be very simple. And then you have to throttle because you are throwing a lot of scale on the processing layer. You will have to throttle on the global level as well and per customer level also, right? Compaction is one of the ideas that I wanted to bring up, but I think this audience has already suggested that a lot and gone through it. But the very simple idea is if in the analytical databases or any big data system, even streaming, what happens is you keep writing. And as you write, the system takes those writes, those blocks of data, keeps it in the background. It will go and compact those if you allow it to or merge in different ways. The idea is to make sure that when the reads happen, these are optimized for reads, right? So that is what we call compaction. So combine smaller files into rolled up bigger files, reduce granularity, right? So the other idea is that, if somebody opens up a graph for last, let's say 3 hours, then he has to see very minute data. If he opens up the graph for 1 month, he can't see every second of data now, right? So granularity has to be changed, right? For the older data, we can see instead of storing per second, we can store per minute, per hour, per day, per week, right? So that we can do. That will give us the room for storing a lot more data now for bigger time because granularity is bigger now. And when you have smaller bunches of data, you can move them faster, less network throughput, less latency and stuff like that, right? So summarizing the change very, very quickly for you, 3 hours to 5 minutes, our crons change, and we deploy it in the phased manner. Yes, this is one thing that I'm going to talk a lot about, and I wanted to be sure. Do I talk on high level when I talk Druid components, or do I talk low level? So quick show of hands. How many of you are familiar with Druid? Okay, I see around 5 to 7 hands. Okay, so because the majority of audience is not very familiar with Druid internals, I'll talk more higher level in terms of query tier, ingestion tier, so that I don't lose track of you. So Apache Druid is basically, how many of you have used any other analytical databases? Sorry? Okay. Any others? ClickHouse, perfect. Sorry? Snowflake, perfect. Okay, so you understand analytical databases. Druid is yet another columnar analytic database, open source, under Apache Foundation, Apache licensed, supports, in fact, not only supports as a tick mark feature, it's really good with both batch ingestion as well as stream ingestion. In the last streaming meetup by Platformatic Group, you had a presentation on how Kafka and Druid work together with real-time ingestion, right? Batch I'll cover a bit today. Segment-oriented design. So this is something that will focus a lot on distributed and modular architecture. For most parts, it's horizontally scalable. I'll show you the architecture and tell you which ones are and which ones are not. Supports data tiering. So you can keep all your data on. In our case, we keep all the data on S3, right? So durable, scalable, no such problem. We will never lose data because S3's reliability is enough for us. So let's go through the architecture. I really want you to focus on this. And if you get stuck somewhere, don't understand something, please raise your hand. I want you to understand this. And then after this, you can just go through the flow of the presentation, right? Historicals. Historicals, like the name suggests, no prices for guessing this one. Historical data, right? And it's a bunch of machines. So it's horizontally scalable component. You have middle managers, right? Middle managers are basically for ingestion. So when you throw a block of data, a file at Druid, that will be mapped to one of these middle manager nodes to ingest it. Then there has to be somebody, right? You have a load balancer in your app, and that load balancer decides which application instance will take your query. You also have the same things here. Historicals, coordinator will coordinate through them. Middle managers, overlord will coordinate through all of those. So all the ingestion tasks will end up coming here, and this guy will decide where it goes. So just take a note of these 4 processes, which will talk a lot going forward, right? And it will remind you in between, right? So there is another real component, Zookeeper. Will not talk a lot about it, but it's a very central component. So service discovery, cluster coordination, somebody has completed a task, other people want to listen to it, some sort of pops up or announcement that I have done some task. Metadata storage, like I said, metadata storage is actually the Postgres behind these 2 guys. And you can use other SQL databases also. Deep storage for us is S3, or you can have SDFS or any another compatible S3 layer. Broker is the one that will handle queries. Router, if you have a huge deployment on production, you should keep routers. Routers and brokers are both stateless. I talked about Zookeeper already, so I'll skip that. Batch and real-time, both you can ingest. But when you write, what you do is your write goes to the router. Follow the arrows, please. And the router will send that ingestion request to overlord. Overlord is the orchestrator, which will choose one of the middle managers to do that ingestion task, which will eventually put the data on deep storage, S3 in my case. Historicals will actually download that data, right? And keep it ready for query. And that will be facilitated by coordinator. When a client comes for reading, right, fires a query, in our case, it comes from the UI or a worker. You fire it on the router again. So router is doing routing for write and read both. Router goes back to broker again for the queries. Brokers are stateless. Broker will go to historicals as well as middle managers. Quick question. Why do you think it goes here? Because there's all the historical data here. Why does it go here? Anyone? Perfect. Yeah. So basically, to explain that, if you didn't hear, because the gentleman doesn't have a speaker, there is older data on historicals. Then some of the new data that is just being ingested could be here. Broker has to combine data from both the sides and give you the answer of the query. Right? And I will, so we will, I said we will talk a lot about these 2 processes, right? In just one, it's orchestrator, historical data, and coordinator, right? So middle manager, what internally happens is every time you have a task, the middle manager process will open up a new JVM process, right? So if you have 4 tasks to do on this machine, there will be 4 JVM processes. We call it 4 slots, right? So if you have 4 slots, you can only make 4 JVM processes there, 1 JVM process per slot. And you can run 4 ingestion tasks parallelly on this. If you want to run more, maybe open up more slots, put more JVM machines, you can do more ingestion tasks parallelly. Historicals, basically, they will have immutable segments. Some gentleman said update, right? These are immutable segments. If you change any data that has to go here, it has to be completely rewritten. That's where it gets a lot of power of high rate of ingestion and query, right? Because it doesn't allow you to change easily. Should try to avoid updates and delete. So these are segments. And compaction, somebody mentioned earlier already, compaction is nothing but trying to say that we will merge this later to make bigger files. Fewer files, bigger files, a lot of files, smaller files. So compaction is that process. And segments is basically immutable data segments loaded, distributed on these historicals in a way, say, let's say we have 4 of them and we have 20 GB of data. All of them will have 5 GB, 5 GB, 5 GB, approximately balanced there. Very quickly, scale. I think I've taken a lot of time, so I'll run through the scale. 18.5 TB of data, 294 data sources, 423K total ingestion tasks. This is a bit old, so 600K now. Around 8 million queries in last 24 hours. If you look at the query peak per hour, it could go around 400K. For ingestion tasks per hour, it could go around 18 to 20K ingestion tasks, right? So we deployed this new design where a lot of big files to a bunch of small files, right? And then we said, fine, it works on the test cluster, it works on the dev cluster, it's okay, right? We don't have a problem. And we have the whole pipeline. If something goes wrong, it'll observe back pressure and everything. So let's try it, right? So we put the first customer on it, and like, okay, no problem. Few more customers, okay, good. And then we said, okay, we are confident now, we will put all the customers. But now we have a huge number of files, right? Any quick guess, which is the process that will crash first? This one, right? So the result of it, so this is overwhelmed, not able to assign adjacent tasks, and these are doing nothing, right? And proof of the pudding, right? I don't know if you can see it, but it says we have 189 running tasks, 189, and 22K pending tasks because assignment is not being done, and the middle managers, the ingesters, are just sitting idle. Number of tasks being ingested, you see how it has changed from around 1,000 to around 8 to 10K. And this is what the machine's CPU said, right? So overlord is the process that you guys guessed would crash. CPU is at 100%, right? Enough of proof. I think I have described most of these. So I'll hand over to Sachin to go through the fix for this and take you through more ingestion issues and more query issues.
Yeah, hi everyone. So as Siv already said, due to the batch to real-time change, we are getting now 10x to 12x small tasks. So first process that died is overload. So we are getting high CPU usage. So first thing that comes to our mind is we will just give more resources to overload process. So that didn't help as much. Eventually, we ended up with bigger DB instance also, which is needed for state management. So I will come to that little bit later. So as we already said, some of the Druid components are horizontally scalable. Some of them are vertically scalable. So as you can see, overload is for task assignment. So it is only leader based. So if we have 2 instances, one will be the leader, one will be in standby. So it acts as active passive configuration. So first, when we increase the resources for overload, it didn't help much. So we needed to optimize how it assigns the tasks. So one we saw earlier is first we need to put some control on the global queue. So earlier it was unlimited. So Druid was taking up all the tasks and it was not able to handle. So we added limit on the global task queue. Let's say it is 5,000. And also one more thing we can do here is we need to limit the number of tasks per customer also. So what this is doing is it is just getting the number of tasks that is pending per customer. If it is already one, we will not submit. We will just retry after few minutes. Yeah, like I said earlier, overload goes to Postgres. Like in our case, it is AWS RDS. So goes to RDS to get the task state, which was taking too much time due to the increase in number of tasks. So that task table will now have so many entries, new entries. For that, we also scaled up the RDS instance size. So this resulted in low CPU utilization, and the number of pending tasks are now less. So we got the ingestion orchestrator now alive. So now once it is running up and good, we will see issues in the ingestion tier. That is basically middle managers now have defined number of slots, but they cannot take up all the tasks. So for that also, we will, like earlier, each middle manager had, let's say, 4 slots, like it is shown here. So we need to add more middle managers so that it can handle. But this will resulted in high cost, right? So like earlier we said, we have compact tasks, which will form bigger segments. So only those tasks now need higher resources, not the normal ingestion tasks. So basically we need to do tiering, like when we go from batch to real-time system. In this case, we are just separating out the compact tasks. And once we separate both the tiers, now we can have more number of tasks in our default tier and less number of slots in the compact tier. So this is one of the ways to optimize when we go from batch to real-time system. So now, once the system is stable in the task side, we can right size our middle managers depending on the number of incoming ingestion task that is coming. So now we got to a optimal size. Just I am here mentioning is first there were 12 middle managers. We went to 24. Then we downsized, like put more slots. After that, we just did tiering, 10 for ingestion, default ingestion, 2 for compact, something like that. Yeah, so now we have resolved on all the issues in our ingestion side. Quickly, I will just go through the query side also. So what will happen in query side? Now so in Druid, we have a coordinator process which takes segments from deep storage, and it based on some algorithm. Let's say we can define disk normalize, then it will try to normalize all the disk size of historicals. We can put cost, we can put round robin. So based on those algorithms, it will assign segments to historicals. But due to too many segments, now the coordinator cycle for assigning is taking more time. So we need to do some optimization there in order to, so to prove this, like now we have more than 1 lakh unavailable segments. So when the customer will query, data from these segments will not appear in the results. So first, as you all know, like we added more resources to our coordinator process, which is like in terms of Java heap memory. So this same big DB, which was already we scaled up, that is being used here. So in coordinator, we have, like overload, this is also a process which is not horizontally scalable. So historical, we can horizontally scale, but coordinator we cannot, because it has to be leader based and it needs to assign the segments based on the assignment strategy. So one thing we did was we tried to reduce the number of segments in one coordination cycle. So there are number of settings. One of them is like max segments to move. You can put it 1,000. Then it will only take 1,000 when it is doing the calculation. It will take 1,000. It will put assigning. So one more, like I told earlier, the simplest assignment algorithm for coordinator is round robin. So it will assign one segments to each historical, and it will lazily assign the segments based on, let's say, cost or disk normalize, those strategy later. But first it will assign the segments based on round robin. So in this case, like our unavailable segments count decreased with these optimizations. Finally, like this is the last one, like the historicals, right? Now they have, as we all know. So earlier there were small segments, sorry, bigger segments. Now, until the compaction is done, there are 10x number of segments. So we have put one offset of 2 days. That means after 2 days, you do the compaction. But before 2 days, we have some extra segment. So for that, we needed to give little more resource. And one more thing here is like there are some in the historical when it assigns, let's say previously it was assigning 10K segments for historicals. Now it went to 100K. So there is some setting called max map count. This this is a Linux kernel setting. It says like how many memory mapped areas each single process can have. So for us, this was going out of limit because the default for this, if you see, for Linux is like 65K or something. So we need to increase some Linux kernel parameters also for like historical to be able to cope up with the new pressure. So in this way, like we got stabilization in our ingestion tier and in our query tier. So we filed a couple of issues in case of overlord, and recently we filed some issues with coordinator also. So also we fixed some of them. Currently we are fixing the others. So if you see, like this one is for task queue, like it was showing some 500 error, and we changed accordingly so that it will show the right error messages and all. Yeah. So with that, we got back to our happy state of Druid cluster.
Right. Thank you, Sachin. So, these are our social media credentials. Sorry, links. You can follow us there if you have any questions. I think we are almost out of time. So maybe I can take a couple of questions or something. And this is the QR code. We will be having a Druid meetup shortly, temporal one also. So if you like these kind of talks or something, please scan this QR code. You can go through the other meetups we are hosting at Nutanix. And then you can RSVP there. Yeah, please. Sure. Correct.
For Druid,
Sure.
solve this. But there is one concern in the solution where
Mhm.
we throttle the customer.
Mhm.
So here it might lead to customer starvation problems, like one customer
Mhm.
not
Mhm.
getting assigned. So how do we put SLA for
Sure,
every
sure.
customer?
So, good question actually. So a bunch of things. We will not lose data because all the data is there in S3, right? Next, we said we will have throttling in two ways. One is global queue, and the other is customer-based queues. And we say that on every customer, the number of pending tasks cannot be more than this, right? Every customer has a dedicated data source in Druid, right? It's like closest to the table thing you can think, right? So every customer has dedicated data source. On every data source, only certain number of pending tasks are allowed. Beyond that, it will throw an error because it's throttling. And the ingestion tier, right? Like pipeline, temporal will make sure that it stops the ingestion for a while on there, right? And maybe it will retry later, right? And on the global queue also, if there is too much for Druid to do, then it will throttle and give out a specific error. And we have told the app that if there is this error, retry after maybe 10 seconds, then retry after exponential backup, right? Retry after 1 minute, 5 minutes or something, right? So that's the way we handle that.
Yeah, but some data in exponential backup may be ingested after.
So we have, like I said, both the query and ingestion tiers are in auto scaling group. So if the cluster is under stress, we will get an alert. We don't auto scale. We still have that single thing because in case of bugs and all, it can just take up a lot of cost. So if we get that alert saying Druid has too many segments, right? The garbage collection is taking too long, things like that, right? Then we go ahead, look at it, and we increase the tier size, right? Auto scaling group just increase the number, right? It will consume. Yes. no. So we don't maintain a priority queue because we think that if we have auto scaling ingestion and query layers, every time the threshold says 80% of capacity already acquired, we go and increase that number. So we don't have a case where people are starving. We subsume that by scaling it out, right? So nobody will ever starve. If we had that case where we had to starve somebody, then we would use priority. We don't need priority here. And I am like very simplist by design. Like I don't want to do something if I don't really need it. Yeah. Yeah. Any other last question? You want to take that?
Yeah, in Druid, like ClickHouse, we don't have all the options, but it has like its own, like in string, it will do that encoding and those kind of. But in Druid, you don't specify any indexing and all. Just sorry, I didn't get your question.
You can cache on the brokers. So brokers are the ones that go through coordinator and historicals, right? So brokers you can cache. You can enable caches, right? Yeah, you can enable caching on both ingestion and query tier. Yes, configurable on the server params. Right. Sorry?
Whatever is the equivalent of clustering key in Druid,
Mhm.
that would give you the performance equivalent to indexing, and isn't that at least I've worked with ClickHouse, and that's where my question is coming from. It's very, I mean, you don't have secondary indexes in any OLAP systems. Whatever you're querying on top of your clustering,
You
it'll
do
good.
have secondary indexes in ClickHouse. You do have secondary indexes in ClickHouse. In Druid, I don't think it's there. In ClickHouse, you do have Bloom filters, min-max indexes, a bunch
Yes,
of them.
they are
Yeah.
basically summaries like ORC or Parquet, where you
Right.
just have the summary, you
Right.
use that information to know whether
Yes,
I should
I
go to
mean,
this file or not.
correct. But
When I say secondary, like something like OLTP, where you have the entire.
I mean, the idea of so see the way ClickHouse, for instance, works is right. You said ClickHouse. We have some time? Okay, thanks. So the way ClickHouse organizes data, for instance, right? Every segment is ordered and the min and the max of there is kept in the primary key and everything, right? Now, you need, if by chance you need to query by other column that is not indexed, then you need a way to index it somehow, right? And min-max is a fair index. A Bloom filter is a fair index, right? So I don't think it is fair to compare it to OLTP systems, man. Like they have been there for 3 decades, right? So there are indexes. I think min-max index is pretty similar to what primary key in ClickHouse does. Although this is ordered data, and that would not be ordered. So it won't perform, like you rightly said, as well as the primary key one will do. It won't, but it will do much better than at what it would do without that secondary index for that querying that column. Yeah.
My point was basically the indexing capabilities wouldn't be very different from ClickHouse or whatever we get in ClickHouse
Yes.
versus Druid, as long as you're doing something on the clustering, basically the
right.
ordering.
If you do that on the one that you have
the data laid out order.
Then it would be much better. If you can't, if you really need to do something else because business changes, requirement change, then you use secondary index.
ClickHouse has something called projection where.
Yes, you can do projections also. Yes, correct.
So did you guys evaluate other like Pino or ClickHouse before zeroing?
So this has been there for 4 or 5 years now, right? We are evaluating ClickHouse. There is a recorded talk of ClickHouse from one of the previous meetups. I can share you that. There is a blog coming up soon as well. So the ClickHouse ones, I'll share those. Okay. Sure.
Thank you.
Yeah. Thank you, guys. I'll be available in the breaks and after all the sessions. So do reach out.